I've been writing. I'm going to be writing.
7.1b, the main focus of this is just finding the domain. But we will reduce these if we can. So remember that with fractions, in the domain, I should write out. Okay, domain, no zeros in the denominator.
I don't think that's our problem.
So in this case, remember, our domain could be any number except for the number that would make 0 in the denominator. So do you remember what we do? We did this last unit. Good. Set your denominator equal to 0. So I go x minus 2 equals 0. Add 2 to both sides, and I get x equals 2. So for this problem, no. My domain is all reals except x cannot equal 2. So x can be any value except 2.
That's easy.
All right. Any questions on 1? Does that make sense to everybody?
Yes.
Why can't I have 0 in the denominator? It'll make the problem undefined. So I can use any number except for that value. Okay, example 2, we're going to do the same thing. Because I don't want 0 in the denominator, I'm going to set this equal to 0 to see which values would make the denominator 0. So we write out x squared plus 4 equals 0. What will I do now? Good, subtract 4. We have x squared equals negative 4. What will I do now? Square root both sides. If I take the square root of negative 4, what do I end up getting?
Imaginary number.
I'll get an imaginary number. So are there any numbers that I could end up plugging in here that would give me 0 in the denominator? If I plugged in negative 2 here, negative 2 squared gives me what? A positive 4. So there is no value that I could put in here that would make a 0 in the denominator. So this answer is what Austin said, all reals. There's no except on this one. Any number will work. And just for those of you, just to make sure, I'm going to write here, x squared equals negative 4 will never equal 0 in the denominator. Yes. So on example 3, we're doing the same thing again. We're taking this denominator, we're setting it equal to 0. X cubed minus 25x equals 0. Okay, the GCF is what? X, so we take out an x, and we have x squared minus 25. Can I factor that further? Difference of squares. So we have x and we have x minus 5, x plus 5 equals 0. If we set each of those equal to 0, we have x equals 0,
We can't have
x
0.
minus 5 equals 0, x plus 5 equals 0.
We have
X equals 0 is done. Here I add 5 to both sides, and I get x equals 5. Here I subtract 5 to both sides, and get x equals negative 5. So how will I end up writing this answer? Domain, all reals,
except 5 and 0.
except x cannot equal 0, 5 or negative 5. Or you could have put plus or minus 5. Okay, questions? Example 4. When is this statement true? The first thing I would do is see if I can simplify this and if it will reduce to be 5. Okay? So, can I factor anything on the top?
5.
I can take out a GCF of 5, and I'm left with x plus 1 over x plus 1. And I'm checking to see, will that equal 5? Okay, x plus 1s can cancel, right? So 5 does equal 5. That works out. So this would be like an always, except when do you think we should be worried about? If you end up with 0 in denominator. So what am I going to do? I'm going to put x plus 1 equals 0. I'm going to subtract 1 to both sides. And x cannot equal negative 1. So my answer is going to be what? B. Always, except when x equals negative 1. So you always want to be careful with whatever would make 0 in the denominator. All right, so let's do the same thing on example 5. We're going to first check to see if this will end up reducing to be x minus 2. So can I take out a GCF? 3, and I'm left with x minus 2 over 3, and we're seeing, does this equal x minus 2? So the 3's can cancel, and we get x minus 2 does equal x minus 2. So this is true. Okay? But then we set our denominator equal to 0. 3 equals 0. Does that even make sense? No. Doesn't make sense. So what do you think this answer is?
No value.
Incorrect.
Or no value.
No, this worked. X minus 2 equals x minus 2, which
Values
means
of x.
for all values. There isn't any value that won't work, right? The only one that wouldn't work is if you got a 0 in the denominator somehow. But there's no way of getting a 0 in the denominator because 3 will always be in the denominator. So since these reduce to be the same, that means it's all values and there's no except. Okay? So it's just for all values of x. All right, any other questions there?